Hello, my name is Enzo Barrett, and today I'm going to demonstrate Maddie, a Kubernetes security dashboard, which I developed over 4 weeks of my internship with Upslope. The first main issue Maddie solves is Cert-Manager debugging. So first, what is Cert-Manager? Cert-Manager is pretty much like the Kubernetes equivalent of Certbot, if you were just running on a typical server, and it manages HTTPS certificate issuing, renewing, and everything, and it just installs in your Kubernetes cluster. One issue while experimenting with Kubernetes during this internship that I discovered is that it is very difficult to debug anything in Cert-Manager. So let me show this typical debugging flow. So first off, you'll see your application won't load and it will have some issue with the HTTPS certificate. So you'll connect to the cluster with kubectl, you'll describe the cert, and you'll get another debugging log that points to a certificate request. So you'll describe the certificate request, and you'll get another debugging log that points to the order. You'll then type in the command to describe the order, and you will finally get the error. But then you'll have to see what that error is, you'll apply a fix to it, and then if it still doesn't work, you have to go through this whole process again. And there's even more to type if you have everything in a specific namespace. So the goal of the Cert-Manager page in Maddie was to show all of the logs in one place together for all the orders and the certificate requests and the certificates. So let me show what that page looks like. So here we can see if a certificate is successfully issued and has no issues, there won't be any logs. But if there's problems, you'll get logs from multiple steps. So you can see this is what the cert logs, and this is what the certificate request logs. So how does this dashboard work? Let me go through how these logs are generated. And it's pretty much doing a very similar process to what you would do by hand, but it's automated. So for the first example, let's say a cert is deployed with an invalid issuer type. So it's a issuer instead of a cluster issuer. So Maddie will it will get the logs for the cert. It will run them through regex if it is unissued, if it's in a failed state or a waiting state. It'll run the message through a regex to find the certificate request name. Then it will look up the certificate request status message, and if that is in an errored state or if it's in a waiting state, depending on which, it will continue iterating through. In this case, it is just in a failed state, so it adds that to the log and then prints the logs for everything. So you can see here's what Maddie would log, and here's what you would get just describing the cert, which pretty much doesn't describe the issue. Here is another example, which is an invalid issuer name, so an issuer that doesn't exist. First, it will describe the cert. If it's in a waiting state, it will push its logs to the logs array pretty much, and then it will run the status message through this regex. And then if it's in a failed state, it will, which this one is, it will push the message to the logs and then output it to the dashboard. So here's what the logs look. You can see the issues right here. Cluster issuer not found, and here it is if you just did kubectl describe certificate. So here's kind of a more complicated issue that's multiple layers deep. So again, Maddie will describe the cert. If it's in a waiting state, it will run it through the regex. This is also in a waiting state. So we'll run the certificate message, the certificate request status message through a regex. then it will describe the order, then it will finally get the error and append that to the logs. And you can see here, you get the error right here, but if you did kubectl describe cert, you wouldn't get it in any of these cases. So now I'm going to walk through each of the certificates with errors that I have deployed to the cluster and show how easy it is to see the error on the certificate on the Cert-Manager page of Maddie. So here's the certificate that Maddie is running off of right now, and it has no issues, but you can also see what namespace it's in, what the name of the issuer is, and what the kind of issuer is. Here's the cert that I had showed in the diagram, which has an invalid issuer. So you can see this issuer name doesn't work. And you can see it's in a waiting status. And you'll see right here on the bottom right, cluster issuer not found. So right away, you know what to fix for that issue. The next one is an invalid issuer type. So the issuer kind is an issuer, but the actual issuer is a cluster issuer. So on the right here, referenced issuer not found. And next is just a completely invalid domain. So you can see it's invalid.upsnope.app, which isn't a real domain. And you can see it's just left in a pending state. The last one is a rate limited cert, but currently it's not rate limited, so it's just still waiting to issue. And once I reload the page, it shows that it's issued.
So before I look at the binary authorization page, I want to first explain what binary authorization is. So your program will almost always be run in a Docker container when using Kubernetes. So binary authorization is a way of verifying that your Docker image you're using to run your container in your cluster is legit. So it applies a policy where you can either sign images with an attester with an attestation, or you can apply a whitelist to the policy, which will allow any image that matches either pretty much the explicit name or a regex.
So now I'm going to walk through the second big feature of Maddie, which is a binary authorization page. Google has a page to view the policy whitelist, but it doesn't show security issues, which Maddie highlights in red. So let me explain why these policies that are whitelisted with stars are insecure. So here we can see docker.io/google/Google star, which will allow anything that starts with docker.io/Google/Google. So this is bad because in case there's an issue with the Google repository, someone could deploy anything that starts with Google. So Google-malware, Google.hackers, and it would be able to be deployed to your cluster without issue. So here's one that is slightly better, which is allowing any version of a specific Docker image, but you can still see someone could deploy a tag with malware, and it would deploy to your cluster without issue. So really the main part of binary authorization is the attesters and the attestations, which means signing an image and really manually allowing it into the cluster and only allowing an image that matches the SHA-SUM. So Google actually doesn't have a attestations view built into their dashboard. So Maddie is pretty much the only way to look at all the attestations without using the command line. Now we're going to look at the third and final component of MADI, which is the cluster security page. The cluster security page is designed to be minimalist and simple. A green check mark is a passing check, a yellow exclamation mark is a partially passing check, and a red X is a failing check. So what are these checks based off? I went through this document from Google called Hardening Your Cluster Security and created questions for each section of the article. So, for example, if I went down to enable shielded GKA nodes, the question would be, are shielded GKA nodes enabled? And MADI will check using various APIs depending on the question, whether shielded GKA nodes are enabled. So let's take a look at the page in MADI. So right now I've deployed MADI to a very insecure cluster where I've purposely disabled any security features that are automatically enabled. So we can see pretty much everything. All these checks fail, except for this one passing check. Are the subjects of system discovery and system basic user curated? So I discovered that Google writes about this in their article, although Kubernetes by default curates the subjects of system discovery and system basic user. But I've left this on as a check in case an admin of the cluster changes things to be insecure, they would see it in the dashboard. So now I'm going to jump forward in time and show MADI deployed on a secure cluster. So here it is, and we can see immediately one of the best features of the cluster security page, which is errors and issues are prioritized at the very top. So there's no way, even though most of the checks are passing right now, there's no way that the failing checks will be buried and hidden from whoever is using the dashboard. Now, the reason why this secure cluster has these two failing checks is because there would just be a lot of additional setup to make it a private cluster and make it accessible by the web and by me for maintenance. So that's why, and master authorized networks is pretty much just the IPs which are allowed to access a private cluster. But we can see the cluster has been set up with all these different features, and they are all showing correctly as enabled on the dashboard. All right, thanks for watching, and feel free to contact me at the websites shown on screen or email me at enzo@barrettinfo.tech. Thanks.